Let's talk about the numerical. Let's see, there are three bodies A, B, and C. Body A is having mass 5 kg, body B 10 kg, and body C 15 kg. Okay, they are projected from top of a tower. This is top of a tower. Okay, body A is projected vertically upwards. Body A is projected vertically upwards, right? With a velocity of 10 meter per second, right? Body B with 20 meter per second at an angle of 53° above the horizontal towards east. Now this is a direction towards east and it is projected at an angle of 53°. This is body B having mass 10 kg, right? So now the velocity of this is 20 meter per second. Body C, obviously this north, this is, east, obviously this will be south direction. Body C is directed towards the, projected towards the south direction or from the top of a tower. Okay, so south direction and the velocity is 15 meter per second. This is 15 meter per second. Now see students, we were until now doing the numericals where A, B and C or N particles were fixed, and then we were finding the center of the mass C for particles A, B and C. In this numerical is a numerical which will give you insight about the velocity and acceleration of the center of the mass. So though they are moving in separate directions, the center of the mass is also moving with a velocity in a particular direction with the acceleration. What will be the velocity and acceleration of center of the mass is this question. So can I get any inputs from any student how we can do it? You see, total mass m is equal to m1 plus m2 plus m3. So that is 5 plus 10 plus 15, that is 30 kg. Okay? So now, before applying these equations, you have to fix your coordinate axis. You can fix them anyway. You might take it as x-axis, y-axis, z-axis. This one as x, y, z-axis. Now this south is, x. You see that if this is north, if this is east and this is south, so you can take coordinate axis anyhow. We have already seen the choice of coordinate axis do not have any effect on the center of the mass properties, right? So we might as well imagine that this direction of you know we can take x-axis along south, we might take y-axis along this, and obviously z-axis along the north. You can take anyone also, you will get the same answer. Okay, so obviously now students, I cap vector is along the x-axis always, right? J cap vector, unit vector, shows the direction of y-axis, and k cap vector shows the direction of z-axis. Am I right? So very intuitively, now can you tell me what is VA vector? Anyone? This is velocity A, and this is our north, right? So this is our x-axis. I've already seen this is our x-axis, this is y-axis, this is z-axis. So what will be VA? Can anyone tell me? What will be our VA? So VA, what is the magnitude? Magnitude is 10. Okay, but it is along which direction? Ishma? This 10 meter per second is along.
J cap.
Not.
You see, this is K, this is a Z axis. So that Z axis is K cap. I think you saw K and J cap or K cap. I didn't hear properly. What will be velocity of B? Can anyone tell me? So see, this is in this direction, but the vectors are only towards the x-axis, y-axis, or z-axis. Am I right? The vectors are never inclined. So what we will do? Yes.
B vector. Component of B vector.
B vector. We will take component of B vector. This is perfectly right. It's a very good sum. So B vector, we will take one component. This component would be what? This would be
B
B.
cos.
This will be B cos theta, and this will be B sine theta. Am I right? So B cos theta is towards y-axis. So this is towards like J component, and B sine theta is towards z-axis. This is our z-axis, right? So z-axis is what? K cap. Am I right? So can anyone tell me what will be VB vector? What will be VB vector? See, it will be 20 into,
20 cos 3 degree.
it will be cos 53 degree J cap. Am I right? And
Yeah.
sine 53 degree K cap. Once you know this numerical, you can do so many other numericals, meter per second. Right? So this will be equal to, once you solve it now, you take cos 53. So this will be, 20 into, you can do it from calculator or the table, J cap plus 20 into 0.8 K cap. So this is equal to what? 12 J cap plus 16. So this is 16 K cap. What? Unit of velocity again? Meter per second. Beautiful. So now, similarly, students, now this I think Ishma should you should tell Ishma or Jinder that what will be velocity of the C particle. See, this is towards south axis. South axis we have taken as x-axis. Towards x-axis we take I cap. So what will be VC vector, Ishma?
15 I cap.
You should also say I would be happy meter per second, right? So very simple. Now we can find out very interesting sum, isn't it, students? So now we can apply this formula that mass into V cap. What is this V vector? This is the velocity of center of the mass is equal to m1 v1 vector plus dash 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 plus m3 v3 vector, right? So total mass, you know what is total mass is 30. So V vector would be equal to, yeah, tell me, come on, students, would be equal to what is M1? M1 is 5, right? 5 into what is V1? V1. V1 is VA. This is MAVA. You can write like this: MAVA, MBVB, and MCVC. Right? 1, 2, 3. So come on, tell me what is VA? VA is 10. Come on, students. 10K cap plus. Yeah, tell me what is VB vector? You have already found out the expression. Just tell me. Yes, Ishma. What is VB?
12 J cap plus 16 K cap meter per second.
Into 12J cap plus 16K cap into mass, corresponding mass. What is the mass of B? What is the mass of B?
10 kg.
So yes, Amitoj, what will be the third component? So MC would be 15
I cap.
into, no, you're wrong.
15.
MCVC vector. So 15 is the mass, and then it is 15 into 15.
I cap.
Like that. Very right. So I give you the homework that you do one thing. You take this one as I, then you take this one as J, and this one as K, and then do it again. And you'll see, you'll find that you'll get the same result. Okay. So this is equal to, students. So when you solve this, you will get this as 7.5 I cap plus 4 J cap plus 7 K cap. You see that it's such an interesting numerical that the particles are going in different directions, 3 particles. Still, you are able to find the velocity and acceleration of center of the mass of the particles. They are moving away from each other. Still, you are able to find out meter per second. Okay, students. So now we will find their acceleration also. Can anyone guide me how to find the acceleration now?
d by dt of v is equal to a.
Okay, so see that here, very simple. Acceleration of A would be, yeah, tell me
d by dt of a.
how we will find d by dt. Yes, what will be the acceleration? So you have to apply your brain. You see that which is going up, going down, going at an angle. So which is going at an angle. So you see that. You tell me how I have written this. Acceleration of A would be minus 9.8 k cap meter per second square. Acceleration of B would be equal to, you please think and tell me, 9.A1, which what it will be? It will be k cap meter per second square, right? And acceleration of C would be minus 9.8, again k cap meter per second. I just want you to think about this. All right. So what will be the acceleration of the, if this is given, just think about this, how it comes. And what will be the acceleration of center of the mass? So you will apply same formula. Tell me the formula, Ishma. MA, come on, MA, A cap, A vector plus, yes, completed, MB, AB vector plus MC, AC vector divided by M1 plus M2 plus M3, that is total M. So this will be equal to, just multiply 5 into minus 9.8 K vector plus plus plus, right, divided by total is 30. So you will have acceleration of the center of the mass would be minus 9.8 K cap. Okay. I want you to think about this, how I took these values without me telling you. Okay. So I'll give you 2-3 similar sums like this. Please do them. Okay, students. Interesting sum. All right, let's do what is angular velocity and its relation with linear velocity. You see, students, linear velocity is, very much understandable from translation motion. So this is a particle moving along some axis, moving along a straight line. So we say this is the velocity in meter per second. This is linear velocity. Okay, when you say angular velocity, so let's say this is a rim of a car or of whatever it is, wheel. So many particles are there, infinite particles are there on every rim. So every particle is having circular motion. You see, every particle is undergoing a circular motion. Okay, but interesting thing on this particular rib of the wheel, all the particles in time delta t, they are traversing same angle. This particle will come here, this particle will come here, this will come here. All the particles have traversed the same angle. Okay, so let us say that angle is theta in time t, right? So basically, when you say angular velocity, when you define angular velocity of a particle, is the time rate of change of its angular displacement. Time rate of change of its angular displacement. Now, what is angular displacement? You see, from here to here it has come. This is angular displacement. This is linear displacement, right? From A to B. And this may be the angular displacement of a particle from A to B. So you see that angular displacement we can take in theta also in radians. Okay. So angular velocity would be angular displacement divided by time taken delta t, right? So this is equal to delta theta by delta t. This is, delta theta angle in small time delta t. Am I right? Now, when delta t, we have already learned limits and derivatives. When delta t approaches zero, you have seen from limits and derivatives how when we calculate average velocity delta s by delta t and we take the limit delta t approaches zero, delta s by delta t becomes ds by dt, right? This is the derivative. This expression is basically the derivative of displacement with respect to time, right? So especially when delta t approaches zero. So this will give you instantaneous velocity. Okay? Like we have calculated the try to calculate the instantaneous velocity when the body was falling, right? With the equation s is equal to 4.9 t square. For this, you please refer the other, other video. Will be giving you the link down. Okay. So delta t approaches zero. So we can say that when this approaches zero, the instantaneous angular velocity, we get instantaneous angular velocity that we will express with the help of Greek letter omega, right? Omega watch is famous. Omega would be equal to d theta by dt. Okay. Theta, whenever we use in trigonometry or in algebra, is never taken in degree, you will take in radians, right? And you know that pi radians is equal to 180 degrees. So I'll give you the link of another video how you can convert degree, then smaller angle minutes, and still smaller angle seconds into radians. So we have a video with that also. I'll just give you a link. You see that also. Okay. So students, angular velocity's unit would be, what will the unit of angular velocity, student? D theta is in radians, dt is in time, so it will be radians per seconds. This is your angular velocity. Okay. So this is done. Okay. Now, see, for rotation about fixed axis,